Today's topic of presentation is a bit of a mouthful. We can talk about how to scale up application. There is a very unique situation where um, a lot of the online businesses, well, all of the businesses have an impact, but many offline businesses have very negative impact from like literally having no foot traffic and no activity. And many online businesses have seen a dramatic, unprecedented impact in terms of the increase of load users request to their businesses. So we're going to talk about what are, we think is one of the interesting ways to solve that issue. Obviously, we're going to look from a context of GridGain and specifically about Apache Ignite, which is the project we're a big part of it. So I guess most of you have heard or instinctively understand the impact of the current challenge. This is a pretty good. If you look at this on the slide, there's an interesting graph. I actually borrowed from a excellent blog from our partner company called GridDynamics. By the way, there's a link. I advise anybody to read this. It's much more kind of high level take on impact on many businesses. But this is a very interesting graph. If you can see, basically, it's actually a demand forecast or revenue forecasting by the companies. And as you can see, before the COVID-19, the forecasting and the actual was very, very close. We're getting pretty good at forecasting. And once the quarantine measures were put in place, there is a dramatic gap between the forecasted revenue or demand, and it's actually pertains to online businesses, and what actually happened. So based on based on number of open source information, there is up to a 10x increase in demand of system load, literally that happened in the span of a few weeks for many online businesses. And obviously, the companies like, Amazon and the Facebook and, like that, they strive in this. They were prepared, or at least, they had, billions in their hands. They had hundreds of thousands of people employed that's available to them, and they can really adjust rather very quickly, be prepared for that. For the lion's share of other businesses, that was completely unprecedented spike. And I'm sure most of you would remember that somewhere in late March and April, where at least in the United States and elsewhere, the quarantine measures were put in place. We had a completely abnormal situations in terms of shortages and outages, and literally business completely unprepared. What also interesting from a technical standpoint is that if we just drop down a level, start talking about the online systems, the latencies and throughput are becoming absolutely critical, both of them, as a matter of fact. And that's an interesting, caveat. We used to talk about either one or two. I mean, either one of them, either latency and throughput. And many businesses made an emphasis on that. Sometimes, like, if it's forex trading, the latency is very important. You don't really have the volume. You really care about latency. And just to refresh everybody, latency is basically how fast a single operation can go. And the throughput is how many of that operations can go in a given period of time, let's say in a second, with the minimal SLAs. And for many other businesses, throughput was the critical. For example, if you online shop, obviously you don't really care if if particular transactions goes extremely fast, but you care that your throughput is sustained, that you can serve the customers. And what we're hearing from our customer base, from a GridGain customer base, is that for affected businesses that have seen a dramatic impact, increase, both latencies and throughput are becoming an absolute nightmare to maintain, because they both affect obviously the user experience. If you don't have latencies, if your operations used to take fraction of a second, now taking in a minute, obviously you have a problem. And if your systems are crashing by processing 10x more users hitting your system, you also basically having a problem. So we're going to talk about what specifically we can offer in terms of the projects and software we develop that can help. But also, we need to understand that we should really stay. It's a very broad conversation if we just basically rise too much in a high level. Based on the conversation with users and customers we have, we really have to concentrate on solutions that have these three characteristics. They should have an immediate impact or effect. So I don't think anybody right now is diving into the 9-12 months projects and to see how we're going to fare in a year from now. Those projects can go, but there is a razor sharp focus on what can we do in the next 2 weeks and months, because naturally the situation we have today isn't going to end fully. As a matter of fact, there is plenty of predictions that in many ways that's the new normal, and the spike we all experienced in terms of the online transactionality will probably stay with us for forever. Because I don't think, and not that I don't think, that analysts don't think that all of a sudden we're going to go back to where we were. So we're probably going to recede from the peak, but up to 70 to 90% of the volume will probably remain the same way. So the long-term projects are important, but they're basically on the back burner right now. What everybody is need to be looking at is what can be done to have an immediate effect. It obviously has to be easy to implement. It kind of goes hand in hand. It has to have an immediate impact. It has to be easy to implement. Again, very few people are looking right now for a complete re-architecture or introducing a complete new technology into the stack, because again, that's not what will give you an immediate impact. Probably the less obvious, but probably the most important, we have to do something that fits into the long-term strategy. And this is something we've seen already a number of times throughout our ecosystem of Apache Ignite and GridGain customer space, is that you should really stay away from a kind of one-off throwaways, because they may or may not have a certain impact within the days or weeks, but if it doesn't really fit general long-term strategy, you basically shoot yourself in the foot, because you're going to be throwing it away. It's a waste of time. You're going to double your efforts to introduce something into your stack and your systems and then take it away and whatnot. So again, the very important on this slide, I think it's just one of the most important, a core thought from this presentation is that you really have to concentrate on some solutions, fixes, solutions, whatever they are, that fits this these three bullet points. It has to have an immediate effect and impact. Consequently, it has to be easy to implement, and it has to fit with the long-term strategy where you want to go. So we obviously we're the company behind originally Apache Ignite project, and I'm going to have a couple of slides about Apache Ignite and the whole Apache, just for if anybody is not familiar with that. We've been doing this for almost 15 years, and I was the original developer of a GridGain project that's eventually become Apache Ignite, and we created the company around this. So Apache Ignite is a memory computing platform. And again, I'm sure we have some webinars, some materials to talk generally about what Apache Ignite is. We're probably not going to spend too much time on this today. And the solution that we're pitching to our customers, and we believe this is a very effective solution that fits all these three categories, again, of immediate impact, easy to implement, and fitness to the long-term strategy, is using Apache Ignite as advanced caching in front of the typical RDBMS, whatever that may be, Oracle, MySQL, Postgres. We support any SQL databases that have JDBC drivers. So we'll talk about this. Essentially, the rest of the presentation will be to give you a much more technical dive into what it is and why, what is actually this distributed transactional right-through caching for RDBMS, how it can be deployed, how it can be worked, what are some of the key features of that. So we'll dive a little bit more technically in this area. So let me just talk about latencies and throughput in the context of in-memory computing. Again, some of that is probably, even if you've never heard about in-memory computing, which is hard to believe, but let's say you've never touched it, you've never used this, you probably have a subconscious sense that in-memory computing something to do with memory. Memory is obviously faster, but many people don't realize how much faster memory is comparing to the disk. So this is a good table. On the left side, we have a certain events, and the third column is a human scaled latencies. So if the one CPU cycle is about 1 second, again, it's just a human scale for us to better understand because we don't really sense nanoseconds very well. So if the one CPU cycle is 1 second, the disk is anywhere between a week and months. But the memory is literally just a few minutes. The difference between the memory and the disk is the difference between a few minutes and basically weeks and months, you know, anywhere from half a week to almost 9 months. So that's the scale of a difference between disk and memory. And this is a profound difference. I always keep, you know, I usually, when I present this, and I've been presenting this, you know, type of ideas for many, many, many years, it's always fascinating to ask people in the audience, and I wish I could ask you right now, guys. But it's interesting to ask, you know, think about what if you need to make something in your system. Let's say you develop an online system, whatever it is. How do you make the system 3 times faster? And I've been asking this question almost for 15 years by now, and the answer hasn't changed. And I get all kinds of answers, you know, but, you know, when you dig down to this problem, how do you make, let's say, a checkout in your online store 3 times faster? How do you make, you know, your banking operation 3 times faster? People immediately start thinking, okay, can I get a 3 times faster CPU? In most cases, no, you can't. Can you get 3 times faster hardware, like, you know, RAM or a motherboard or a bus on the motherboard? No, you can't. Can you rewrite your application from Java to assembly? Yes, you can, but it's unlikely that you're going to get 3 times faster operations because it's not a mathematical, you know, computations. So when you really kind of peel off this onion, you will quickly realize that even if we're talking about 3 times faster, let alone 10 times, just a 3 times faster, it's almost impossible. Yes, if you have some, you know, inefficient algorithms, you can change the algorithms, and that's the one approach. But we're assuming that the system is well built and you're using the appropriate algorithms. So about the only thing you can do, and that's not a kind of fleshy statement, that's a very technically rooted statement, about the only way you can do today to achieve this 3x performance or 5 or 10x performance is to use this delta between speed of disk and speed of RAM. And there's a lot more to say here, but just remember this idea that moving data from a spinning disk or a flash system based systems to a RAM in a distributed system is about the only way today where you can gain this differential in terms of its performance. There's almost nothing else available to you as an engineer. So it's a very interesting fact. And talk about scale, that's actually, when you think about scale of databases, SQL databases today, the SQL databases don't scale. You know, you can have some rudimental sharding, or some commercial databases can be put in some kind of, you know, a small distribution like a 2 or 3 nodes, but typically SQL doesn't scale. SQL in its generic form that was developed in, you know, mid-70s, it's not made for scale due to problem with joins and data shuffling. And that's why you don't see really a scalable SQL databases without, you know, significant modifications, especially when talking about, you know, the basic databases like your Oracles, your MySQLs, the Postgres and whatnot. Again, you can shard them, right? It's basically sharing us an architecture where you have to maintain manual shards, and you can do that, but that's basically almost like having the multiple different disconnected databases. When it comes to in-memory systems like Apache Ignite or GridGain, they are natively distributed by design. I'm not saying we're smarter than anybody who's developing database, absolutely not. But by design, this system was designed to be distributed from a day one. And that's why we have, many installations with hundreds of nodes, and we have, I think, a number of installations with over thousands of nodes in the cluster. And that's definitely a dramatic difference between, something like Apache Ignite or a traditional database. You will never find a Postgres or MySQL with more than 2 or 3 nodes in a non-sharded distributed fashion. In sharding wise, you can find pretty significant clusters, but again, sharding has nothing to do with distribution. When we're talking about distribution, we're talking about a distributed transactions, a fully supporting SQL, MapReduce type of operations, fully clustered operations, and whatnot. So when it comes to throughput, in-memory computing systems are one of the best systems available today. That's actually, a lot of people don't realize that, because when we talk about in-memory computing system, people kind of latch on the word memory and thinking that we're talking about moving data from disk to memory. Yes, and that affects latency. What many don't realize is that in memory computing systems today, and not only Apache Ignite, by the way, Apache Ignite is just one example of that, are the most advanced distributed systems. And it came historically because, in 20, 30 years ago, when this whole technology started to shape up, you had to connect multiple computers because RAM was so scarce. And from those days, it's a highly distributed systems. They were developed as highly distributed systems. Just a few words about Apache Ignite. Again, very quickly, if you guys know what Apache Software Foundation, it's a home for projects like Hadoop, Kafka, Cassandra, and the whole Apache web server originally was there. So Ignite is in the same family. We routinely ranked as one of the top 5 projects with many millions of downloads and whatnot. So we're in a good family. It's a very good place for enterprise open source projects, and we basically in the same family. Just a very few words about Apache Ignite. Again, we're not going to spend time here. You can find a lot of this information and elsewhere, including our webinars and just the documentation of Apache Ignite. Apache Ignite is an in-memory computing platform, and the word platform, I typically don't like the words platform because they kind of too amorphous, but Ignite essentially is all in all in-memory computing library and APIs. There's plenty there. There is a distributed in-memory tier that basically can work with both memory and disk, and this very unique capability of Apache Ignite that it can actually spill data onto the disk when memory is not enough, and really be very transparent to you. So you can keep terabytes and petabytes of data in Apache Ignite with only small fraction of that kept in memory if you need to. There is a both data grids and compute grids and service grids available to you, so you can do data distribution, you can do computational distribution, so you can run parallel computing, and there's plenty of APIs like key value and SQL and transaction and messaging and streaming. There is a very rapidly growing ML library and whatnot. So it's a very deep and wide platform. Just like any platform, you don't have to use all of it, obviously. The really cool thing here is that you can pick and choose whatever you like and whatever fits your projects and needs, and use just that. And by the way, on this picture, whatever's in gray is what's available in GridGain. And GridGain essentially acts as a company that provides services and commercial features on top of the Apache Ignite. Think Cloudera, Hadoop, the GridGain Ignite. It's the same story. So I want to spend the rest of it, which we have probably about half an hour at the most, just talk about some of the aspects of how. Remember, like in the previous slide, I told you that Apache Ignite is a very broad platform. When you look at the first time, you can really get lost. I mean, there's so much functionality, so many different aspects and functional areas, and what do I do? So let me concentrate here on the idea that you have an application system today that essentially built in a very traditional shape and form. You have essentially application layer, you have a database where you store information. And let me tell you where and how we can help, or how Apache Ignite can really help to alleviate the problem with the latency and throughput. So the Apache Ignite can be deployed in many different ways, but there's 2 main areas how it can be actually used and deployed. And one is distributed cache. or another way, as actually full-fledged database. So on the left, you have a diagram for the cache. Again, these diagrams, very similar. So on the left side, what you see basically, there's application layer on top. It's whatever your applications are, right? And on the bottom, you have a traditional existing data sources. And typically, it can be whatever you have. NoSQL, SQL, Hadoops, any other store. We practically support almost everything under the sun, anywhere from Cassandra, Hadoops to RDBMS SQL and anything else. The picture on the left is what I would propose to be, because this is basically one of those unique situations where you don't have to replace anything. Remember those three bullet points I mentioned, the immediate impact and easy to implement. So the picture on the left is really the easiest one to implement, because if you have your data stores, you don't have to touch them. You only slide in between the Apache Ignite layer, and that will give you both latency and increased throughput. And we'll talk about how in a second. But picture on the right is something you can do as well. You can basically completely eliminate, if possible, in your architecture, any existing data stores, because Apache Ignite can act as a practically normal database. It has full SQL 99 support and a full transactional support. It has JDBC driver, so you can literally take an Apache Ignite with all of its in-memory capabilities and really use it as a normal database, quite literally. It most likely will require a little bit more legwork, unless you have very well-defined demarcation between your applications and database can literally easily be replaced. In many situations it can, but again, probably the easiest way is the picture on the left, is where you're just sliding the Apache Ignite cluster in between. And this cluster will act as the essentially latency and throughput layer for your applications. So let me just talk just a little bit in details. What does it mean to be distributed right through cache? And that's the picture on the left is now basically moved to the picture on the right here. That's the picture with existing databases still in place. So first of all, the Apache Ignite layer is a scalable, horizontally scalable in-memory storage. So you can have just a one database, or no matter how way it's shorted, but you can have 1, 2, or thousands of nodes, if you like, of in-memory cluster based on Apache Ignite. And it will provide you both SQL and ACID transactions or MapReduce functionality that you can run on it. There are two major ways how this layer will be synchronized with underlying storage. Let's say your databases. The write through, which basically means that every time you write a value on a very kind of low level into the in-memory layer, it will be written through to a database. Now, it gives you a rather comparable performance for writes as a normal database. As a matter of fact, your writes probably going to be even slightly slower. So if your writes are a problem or performance bottlenecks, you have to be aware of that. But you get basically full transactionality here, because essentially for every write, you open transaction and you write it back to database. There's also another mode called write behind. In this case, we accumulate those writes in memory layer and we buffer them for synchronization with a underlying storage. In this case, you get dramatically faster write, because again, you don't synchronize. Essentially, if you think about it, you don't f-sync every write to memory to underlying database. You buffer them up and you do it in batches. So in this way, you lose certain level of transactionality. You get only eventual consistency between your layers, but you get dramatically faster performance on the writes. What's really important is that in both cases, you get tremendous increase in performance for reads. And that's the fundamental property of any caching system. So your typical read performance will go at least probably 2 levels of magnitude. And that's where you can get an extremely easy way a dramatic performance increase, both latency-wise and throughput-wise, through Apache Ignite. So this is basically the easiest way to get this. It's a very important slide here because the rest of it is going to be a little bit more technical. We're going to give kind of, dive deeper in some of the distribution and partitioning logic that Apache Ignite employs. But this is, the higher level enough picture of how can you get our significant performance gains with very little investment of time and resources. So again, it's an open source Apache Ignite. Just slide it in, configure it properly. There's some code changes that needs to happen. Obviously, you have to reconfigure to talk to Apache Ignite cluster. You have to configure it properly with the right behind and right through behavior. There may be some changes to the SQL, and we'll talk about it in a second. But fundamentally, this is the picture of how you can get dramatically faster read performance and potentially faster writes to your system if you can relax some of the transactional behavior. In most cases, we're finding that customers can relax those transactional behaviors. Sometimes you can, obviously, and you have to endure the full transactional behavior, and your writes not going to be much faster at all. But for many applications, the eventual consistency is good enough, and this way you can gain significant performance even for writes. Let's move on. So now I have like literally a series of slides in terms of the data distribution and partitioning, and that's a little bit of a primer of why a smart partitioning, and you're gonna hear terms like affinity-based collocation. It's a mouthful, but I'll explain what it is. This may sound a little bit technical, but this is the fundamental idea of why Apache Ignite can attain such a massive throughput. And you will see that if you do it in a default way without a proper collocation, your typical distributed operations like SQL joins, for example, would be horrifically slow due to data shuffling. And only when you do the proper collocation, which is, believe me, done by any serious systems in the world today, distributed system, data processing system, you can achieve very scalable performance. So let me explain in a series of slides here why it's important. So let's take an example where we have two nodes cluster, and we have two tables. We have a country table and a city table. So if you just randomly sprinkle this data throughout the cluster in some kind of even fashion, right? You end up with this particular setup, for example, where Canada's in the node 1 as a country table, right? I mean the row. I'm talking about the rows. So tables kind of logically spread over the cluster. I'm talking about the rows. And France is on another node, and again, the left node has rows for Toronto and Paris and Calgary, and the right node has the rows for the cities. As you can see, the nodes that actually has the yellow background, I mean the rows, I'm sorry, is in the wrong place. They're not collocated with the countries. So the Montreal and Ottawa are basically on the same node where the France row is from a country table. So that leads essentially to a very inefficient SQL query. And that actually applies to any distributed operation. Doesn't really matter. It's a map-reduced full scan or a SQL, because for us, we translate SQL to those, kind of, assembly level operations. So they all suffer from the same fundamental problem. And this, by the way, the fundamental problem of general SQL, that if you just, are naively distribute SQL, it's just not going to work, because simply for the fact that you're going to have this problem that we're going to describe. So imagine that we have a very simple SQL query. You can see it on the slide. Simple select with the join. And if you just mentally think what's going to happen, so we're going to send this query to all the nodes for localized execution. And you're going to basically endure this data shuffling operation, because for the join to work, you have to have all the data for all the tables in some kind of common place. So obviously there's no common node big enough to sustain all this data. So data has to be shuffled between two nodes. And that's what fundamentally kills any performance of distributed joins or distributed operations or distributed SQL operations if you don't have a proper collocation. Now, truth be told that, nobody in the right mind does this today. 40, 50 years ago, people were basically hitting this problem. Today, you have systems like Apache Ignite or CockroachDB or something else like Google, Spanner that allow you to solve this problem. As a matter of fact, the reason I mentioned those three projects, they're very similar in how we approach this problem, how we solve it. We can explain it in a second. So if you read about Google Spanner or CockroachDB or Apache Ignite, we all solve it in a very similar fashion. So obviously this is bad, and this is, will not only not increase your throughput, it will kill your throughput because your entire system will be basically bottlenecked with the data shuffling in the data exchanges. So the way to do it, obviously, is to collocate. And the collocation cannot be done in general. You have to tell us, you the engineer, you have to tell Ignite or any other system how to collocate. And the way you do it is obviously, not obviously, but the way to do it, for example, in Apache Ignite is to, when you create a table in a SQL, and that's essentially, just an example of how Ignite supports SQL, you have to tell the city table that it has to be collocated with essentially with the country code. And the country code is a code of country. It's a three-letter in the country code. I think it's ISO code. And it's basically the same code as exists in the country table in the code. So the city table has the compound primary key, which is basically just an ID, technical primary key, and the country code. And we're telling that the city table has affinity key of a country code based on the country code. So the affinity key is very important. That's a linkage. How we're going to collocate independent pieces of data on a single node. So obviously there's more to this. I mean, I'm simplifying it, to the certain level. There's more to this, how we support distribution and partitioning, but the affinity key is the key here. So once you have that, every time you do the inserting into the Apache Ignite, so you basically just execute simple in a SQL insert, we will place this record in a proper node so that later on, when we do distribute operations such as SQL join, for example, I'm talking about the SQL here anyways, we can actually avoid any data shuffling. So this actually slide shows how affinity key gets translated to the node. Again, this topic in itself is worth the entire presentation, by the way. Just a quick note, we're using the same kind of, the rendezvous algorithm that's used, by many other projects, Cassandra using the same algorithm, but we have a slightly more advanced here. But we map the affinity key to partition, and partition is mapped to nodes. So every node can have multiple partitions in it. That's how we basically handle the backup, replicas, and whatnot. But what you need to understand is that once we have an affinity key, we can pin this to a particular node. And once we have that, exactly the same SQL query, will go blazingly fast because now it's fully parallelized. Portion of it runs on node 1, portion of it runs on node 2. We aggregate results back and give you back a normal result set from your SQL query. So as you can see, there's no data shuffling here. So it is a very important point. I know it's a little bit technical. I know we're jumping, in kind of skipping lots of details technically, but fundamentally, this is the idea behind any distributed systems today. How can we get this massive throughput? Forget about latency. Latencies are pretty simple, right? Because again, remember, latencies is just the fact of moving data from a slow medium disk, flash, to a fast and medium like RAM. That's your latency. The throughput comes from this idea of collocation. It's as simple as this. If you don't collocate, if your data are not properly linked through Affinity, you will never get throughput because you're essentially, in most cases, you end up with the full scans. In case of a SQL, you end up with a worse situation because you have to shuffle data back and forth. And as a matter of fact, multiple times based on your execution plan for SQL. So the proper collocation is absolutely essential for any distributed system that deals with the massive amount of data. So Apache Ignite has a very advanced system for selecting affinity keys. I showed you just a small example in SQL. You can do it with or without SQL because SQL is just one of the interfaces that Apache Ignite support. You can do it in a key value. You can actually do it in a very programmatic way. We support very advanced MapReduce type of operations that you can code in any language, any JVM language, Java, Scala, Kotlin, and you can use the affinity there as well in a very programmatic way. And many of our users and customers do that. If for example SQL is not expressive enough, you can just drop down to the code level and really code a very intricate logic with affinity collocation as well. But one more time, the affinity collocation or just proper collocation is absolutely essential step. It's almost a binary function. Without it, your system will be dramatically slower than before. With it, that's the only way to get advantage of this massive distribution that you can get with Apache Ignite on the data processing. Let me just a couple of more slides before we can start with the questions. Just a few words about the transactionality. So Apache Ignite being a distributed system, it supports distributed transactions. As a matter of fact, we support both eventually consistent transactions, we call kind of relaxed consistency, and we also support full ACID two-phase commit transactions. So if you need and when you need it, we support normal two-phase commit transactions. So no gimmicks, no shortcuts. It's exactly the same transactional behavior, consistency behavior you will find in any normal databases. If you need to move money between accounts, if you need any of this transactional operations, you can do it with Apache Ignite in distributed fashion. One caveat: the two-phase commit transaction on SQL is an experimental mode still. Very few projects actually do that. We have experimental mode, but when you run the MapReduce or key value, you have full support for two-phase commit protocol if you need it. Again, you always have to be careful because two-phase commit has significant performance implications. It's just an expensive protocol to run. So you can run atomic caches most of the time. But what's really unique about Apache Ignite is that when you need it, you have it. Because most of any other projects, when you need transactions, you basically out of luck because they only support one way of doing transactions. Apache Ignite has been unique in the sense for many, many years that we support both relaxed transactionality and a full two-phase commit protocol as well. Just a couple of words about, what's the difference between GridGain and Ignite. So as I mentioned, I'm going to spend just a few words here. GridGain is a company. Think of it the same ideas, Confluence and Kafka, Cloudera and Hadoop, and GridGain and Ignite. GridGain provides a training services. We're about to launch the managed service offering for Apache Ignite and GridGain. We also provide, quite a bit of a extra functionality, if you will, on top of Ignite. So, for example, we provide enterprise security, enterprise level security with audit and cluster node authentication, fine-grained authorization, full integration with JS and LDAP and Active Directory and Kerberos, and all of that. We also, one of the interesting functionality we provide for our enterprise customers is a Datacenter replications, which is very advanced stuff. So not only can you have a large clusters of GridGain nodes in this scenario, you can also have those classes to be federated across the globe, at least on this planet. And you can have various scenarios how you can basically synchronize those clusters transactionally and non-transactionally. You know, we have active, and active passive scenarios supporting as well. So, but you can read most of it about, you can read all about, you know, the difference between GridGain, Apache Ignite, and GridGain.com website. I'm not going to spend too much time here. So I believe this is I believe it's my last slide. So we've got to open this for questions. By the way, obviously, thank you for joining. And you can, just the 2 URLs on this slide. I really advise everybody to look at it. Obviously, in the next just 45 minutes, we can only mention certain things. You can find a lot of documentation, def lists, user lists, all of this wealth of information on ignite.apache.org website. Plenty of examples, plenty of documentation, as I mentioned, and obviously GridGain.com if you need or interested in commercial support and offerings. Venkat, back to you.
Awesome. Thanks, Nikita. That was great. Audience, if you have any questions for Nikita, you can enter them in the questions panel. I also wanted to let everyone know that I have shared a link in the chat window for our next webinar that is scheduled for the same time next week. The webinar will cover the last topic that Nikita mentioned, data center replication. And you can sort of understand how to ensure high availability of GridGain clusters. So we hope you check that out. All right, time for questions. First question, how does advancement in flash memory, for example, NVMe, have any impact on the overall IMC architecture, maybe going forward?
Yes, it's a good question, and and does anybody have an hour? Because it's obviously a long comment. There's no a binary answer here, yes or no. So the bottom line, we have to separate it's not about just a, let's say, DC Optane memory from Intel or Micron, for example. We have to separate how this memory is used in the system. If it's used as a non-volatile RAM, so when your Java application just all of a sudden sees, multiple terabytes of RAM, that's a one story. That RAM obviously is slower than a DDR5, for example, but it's relatively the same zip code, if you will. I think it's like 3 to 5 times slower. So it's not like dramatically slower, but the capacity of it's pretty large. The point here is that this has to be byte addressable DRAM. So it has to be interfaced to the system, to the BIOS of operating system as a RAM. In this case, we essentially can take advantage of that. For many, many years, we're no longer bound by a garbage collection in Java. We do our own memory management, so we can easily take advantage of terabytes and terabytes of data that may be available on the system. However, if the same RAM, like an Optane from Intel or anything else, is just a fast disk, which is what predominantly is available today, the faster disk doesn't do anything good for in-memory systems. I mean, it doesn't make any advantages. Doesn't give us any advantages. For us, it's just this disk. Yeah, it gets a little bit faster. So of course, nobody in the right mind today using a spinning disk, right? It's pretty much gone, other than backup reasons. But even Flash is 100 times slower than RAM. Doesn't matter what interface or what medium, because it's not only about the physical substance of how particular Flash works and what interface it's used. It's basically just the way the operating system interacts with it, right? The disks are usually block addressable. They are very expensive cold chain to get from application to actually getting the byte of information. Think about this: in order to read a single byte, you have to read the entire block generally, and you have to go through a very deep stack of calls in operating system and BIOS. While in memory, when we talk about a byte addressable RAM, in order to read a byte, all you have to do is arithmetically increase or decrease your pointer. So we're talking about literally in nanoseconds versus microseconds in a very lucky scenario. So that's kind of a long answer. The short answer is that it doesn't really affect in-memory computing in any significant way. Because again, if the new non-volatile RAM used as RAM, we can use it today. It just basically all of a sudden a particular node would have dramatically more RAM available. Great. Systems like software like Apache Ignite and GridGain can use it right away. If it's a disk, again, we can use it right away. It's just a faster disk. It doesn't really change architecturally anything for us.
Great. I have a couple of related questions. How does Ignite or GridGain compare to some of the other IMC solutions? And also sort of related, how does this compare with other open source projects such as Spark or Storm?
Well, Spark and Storm, I think it's really not competitive. They're more synergetic to us. There are many, I wouldn't say many, but there's probably at least half a dozen commercial and open source in-memory computing platforms project. Obviously, I'm biased. I think that Apache Ignite is the best of the best of the best. But, it's pretty obvious. What I would usually advise people is to try. At least almost all of the projects today, and I can name it. It's a Apache Ignite. It's a Apache Geode. There's two projects in the Apache Foundation that actually deal with the memory. There's a company called Hazelcast. You can try Hazelcast. It has an open source version as well. I think Gigaspaces is one of the old remnants. I think they do have probably open source versions. So I would always say, take everything that I say with a grain of salt. I'm the guy who started the whole Apache Ignite and GridGain many, many years ago, so I'm definitely biased. So try it out. Try it out. It takes a little bit of a time, but there's no better way. Don't listen to the biased individuals for the advice what to use. Listen to me in terms of the what does Ignite do. But try it out. It's a big investment in terms of the big in-memory computing platform generally. So it kind of makes sense to spend a little bit of a time and see what works best. All of our customers, and I talk about commercial customers at GridGain, typically run in comparison between the 2 or 3 projects right away when they try and select a particular memory computing platform. So they obviously talk to us, talk to our competitors, and they try it. So I wish I could tell you some silver bullet feature that we have and nobody else have. We have a bunch of those, but nonetheless, it's the best way is to try and see what works better.
That's good advice. All right, 2 more questions. How do we go about optimizing the nodes in the cluster? For example, do you recommend many smaller nodes or a few larger ones? How do you go about figuring that out?
It's a good question. Generally, I would advise against a large clusters. Yes, we do have couple of installations with almost 1,000 nodes. This is unusual, and I would never advocate for it because the cost of management of such cluster is enormous. It's not that we don't have that we are not supporting it. We obviously do. We have customers like this. Now, do we test regularly with these sites? No, we don't. And that's one of the reasons. It's a very honest answer. We don't test with thousands of nodes. We rarely test with hundreds of nodes. So stability of the system on the large clusters is always subject because we just can't. We can't test, every feature, every commit against the thousands of nodes in the cluster. So the stability of a system is much better when the number of nodes is smaller. And I always advise to use federated clusters. So use multiple clusters instead of one big one. Now, in terms of the particular node, the configuration of a node, that's actually much more, it's much less relevant. Use whatever you have in your local, data center or in your favorite cloud providers. So lots of customers running us on AWS and Azure is, and basically whatever both of them have a memory-centric or memory-intensive instances available, specifically AWS. So many of our customers who basically run a significant clusters run a memory, high memory instances for our applications. Again, by the way, I frequently ask, what is the ideal size of a cluster? And it's a silly question because it really depends on lots of factors. But I would say anywhere between 4 nodes to, let's say, 64 nodes. I would say that's ideal, because forget what we at Apache Ignite or GridGain can test. What is it you, Mr. Customer, can test, can have a staging environment, testing environment? How many customers can afford to have a 500,000 node staging and test environment? Unless you're Facebook and Apple and Google and Amazon, you can't. It's just too expensive. So there's always just economical and practical reasons to have a smaller cluster. It's easier to test, it's easier to stage it, it's easier to have a hot swap or backup, and it's just a lot easier to manage this way. So again, there is a practical engineering reasons, and there's a practical economic reasons to have a smaller clusters, anywhere from, let's say, 2, let's say, to, let's say, 64, something like this. That's kind of ideal sweet spot. And if you look at our users and customers, that's exactly where they fall, by the way. If you look at our bell curve, remove the outliers, and we're going to be exactly in that range between, just a few and, let's say, and a few dozen nodes. That's a sweet spot for any distributed system, by the way.
Awesome. And the last question is around Hadoop. What kind of performance improvement have you seen with GridGain running over Hadoop?
So for quite a few years, we had actually the whole packaging of our product called Hadoop Accelerator. However, in the years that we've actually had it and had customers using it and deploying it, we found a pretty how do I say that? Ugly truth. There is no way to automatically speed up Hadoop. So you can speed up Hadoop payloads by re-engineering them. But then you basically can do it on Spark, you can do it in Ignite, you can do it elsewhere. So I don't think that I don't think that taking Apache Ignite as a kind of, a drop-in silver bullet for Apache for Hadoop is the right approach. It may speed certain things up, but maybe you get twice as fast on some jobs. But we've seen plenty of examples where you get no speed up, or sometimes you get slower because of myriads of reasons. So I would say that probably the best way is because Hadoop is an analytical platform, right? No transactions, and Hadoop was never designed for speed, by the way. That's a massive misconception. Hadoop is designed as a cheap data warehouse alternative. That's what it's designed for, predominantly with HDFS and the MapReduce. So Hadoop was never designed for speed and performance. It was designed for cheap capacity. So if you have a problem with performance in Hadoop, I would suggest move to a combination of Spark and Ignite. Spark will give you the same tooling that you're hopefully using by now, which is the better version of a MapReduce, kind of next iteration of it. And Ignite has tremendous integration with Spark. So we can help you with all kinds of Spark-related tasks, like keeping your intermediate, results in memory, give you the better distribution, and we have both integration with RTDs and data frames and whatnot. So that's a whole. I think we have plenty of information about this, by the way, somewhere on the website an Apache Ignite website. But that's kind of my advice to anybody who's looking to speed up Hadoop. Don't look at Ignite as a silver bullet. the closest thing to silver bullet would be a combination with Spark and Ignite, but you have to move away from MapReduce, legacy of Hadoop. I don't think anybody has kind of drop-in, accelerator for Hadoop. Hope I answered the question.
Awesome, thank you. That brings us to the end of the Q&A section. As I mentioned earlier, we have recorded today's session. We will send an email out with a link to the recording and the slides shortly, so watch out for that. There are a number of new Apache Ignite webinars that we have added to our website recently, so please take a look at those as well, and we hope to see you in one of our future events. Thanks, Nikita. Thanks, everyone. Have a good day.
Thank you, everybody. Have a good day.